The triple points of neon in carbon dioxide are 24.57 Kelvin and 216.55 Kelvin respectively. Express these temperatures on Celsius and Fahrenheit scale. So it's a simple question. So we have two temperatures which is given in the Kelvin, and we are asked to express these temperatures in Celsius and Fahrenheit. And we know temperature at Kelvin is equals to temperature at degree Celsius plus 273. So if it is 0 degree Celsius, then in Kelvin it is 273 Kelvin. So using that we can temperatures in Kelvin, respective temperatures in Kelvin. And so here we are asked to find the temperature in degree Celsius. So T at degree Celsius will be equal to T at Kelvin minus 273.15. So using that we are getting the first result. And for Fahrenheit, what do we know? We know the relation. The C by 5 equals to F minus 32 by 9. So yes, you can substitute the value of C here, so that you are going to get the value of Fahrenheit. So that is simple. A steel wire is to be fitted onto a steel shaft. The outer diameter of the shaft is 8.7 centimeter, and the diameter of the central hole in the wheel is 8.69 centimeter at 27 degrees Celsius. To what temperature should the shaft be cooled for the wheel to slip the shaft? The coefficient of linear expansion of steel is 1.2 into 10 power minus 5 per degree Celsius. So here the diameter of the shaft is 8.7 centimeter, and diameter of wheel is 8.69 centimeter. And the question asks this: how much temperature, to what temperature the shaft must be cooled so that the wheel is going to slip on the shaft. So we are going to cool the shaft. Okay, the shaft is going to be cooled. Okay, so it should be reduced from 8.7 centimeter to 8.69 centimeter. So if the diameter of the shaft is reduced to 8.69 centimeter, then the wheel can slip. Okay, so delta L is equals to L alpha delta T, we have just seen it. So delta L is equals to L final minus L initial. So here it is simple, delta L is nothing but change in length, that is L final minus L initial. So what is L final? The final, so here we are going to cool the shaft. Okay, so you have to consider the values for shaft only and not for the wheel. So for the shaft, the initial temperature was 8.7 centimeter. Now we are going to cool the shaft. So if you are cooling, there will be a contraction taking place. So its final length will be 8.67 centimeter. So what is the final length for final diameter? It is 8.69 centimeter minus what is L initial point? It was 8.7 centimeter. So it is minus 0.01 centimeter. Okay. Now delta T equals to delta L by alpha L. So why we are why we are finding delta T? Because we should know what is the final temperature. So for finding final temperature, we should know the value of change of temperature. So to find the change of temperature, we should know value of delta L. So from this, delta T equals to delta L by alpha L. Okay, from this only we are writing this one. What is delta L? It is minus 0.01 centimeter. What about alpha? So that is given in the question, I think. Yes, it is 1.2 into 10 power minus 5, and that is given in the question. Into what is the original length? So we are here again and saying it is for shaft. So for the shaft, the original length was 8.7 centimeter. So you have to consider 8.7 centimeter. So delta T equals to minus 95.8 degrees Celsius. So this is the value of change in temperature. So what is the change in temperature? So delta T is nothing but T final minus T initial. So here again, everywhere change means it is T final minus T initial only. So from this, what we have to find, actually we have to find T final. So T final equals to delta T plus T initial. So what is delta T? It is minus 95.8 degrees Celsius plus what is T initial? So initially the temperature was taken at 27 degrees Celsius, so it is 27. So the answer is minus 68.8 degrees Celsius. So we have to cool the shaft to this temperature, so that it should be cooled to minus 68.8 degrees Celsius, so that the wheel can slip on the shaft. A hole is drilled in a copper sheet. The diameter of the hole is 4.24 centimeter at 27 degrees Celsius. what is the change in the diameter of the hole when the sheet is heated to 227 degrees Celsius? The coefficient of linear expansion of copper is 1.7 into 10 power minus 5 per degree centigrade. So now the initial diameter of the hole was 4.24 centimeter and the temperature was 27 degrees Celsius. Now they are asking us what is the change in diameter, that is delta L is what is being asked. Okay, now the final temperature is 227 degrees Celsius and the coefficient of linear expansion, that is alpha, is given as 1.7 into 10 power minus 5 per degree centigrade. Now they are asking us delta L. So delta L is equals to L into alpha delta T. So what is L? That is the initial length, that is the initial diameter, here it is. So what is the initial length? It is 4.24 centimeter. What about alpha? It is a coefficient of linear expansion, that is 1.7 into 10 power minus 5. And what about delta T? So here it is T final minus T initial. So it is 227 minus 27. 227 minus 27, that is 200. So the answer delta T, we are getting it as 0.0144 centimeter. So the diameter of the hole will increase by 0.0144 centimeter. So what we are getting? So here it is. So here it is not delta T, it is actually delta L. So delta L is equals to 0.0144 centimeter. So if the initial length was 4.24, then the final length will be 4.24 plus 0.0144 centimeter. So that we have to understand.